10 Cosmic Microwave Background, the universe's oldest message. When we look at the universe, we don't only see stars and galaxies. There is also another light coming from every direction, very faint but constant. This light is a leftover trace from the Big Bang. When the universe was still very young, everything was extremely hot and dense. Once light became free to travel, it spread out in all directions. As the universe expanded, that light was stretched, cooled, and eventually turned into microwaves. That is what we call the cosmic microwave background. No matter where we look, it comes to us, from the right, the left, above. Because of that, we are seeing the same past in every direction. This light tells us something simple but huge. The universe had a beginning, and the evidence of that beginning has not been erased. In fact, when we look at the sky, we are seeing the universe's baby picture. And the strangest part is this: it is the oldest message ever received from the universe. 9 brown dwarfs, the ones that never became stars. There are objects in the universe that are neither planets nor stars. They are called brown dwarfs. Brown dwarfs are celestial bodies that were born with the potential to become stars, but failed to complete the process. For a star to be born, nuclear fusion must begin in its core, hydrogen atoms merging and producing energy. But the brown dwarf is not large enough. Its mass is not enough to start that process. The result is something strange, bigger than planets, smaller than stars, and a cold, dim object that produces almost no light of its own. That is why brown dwarfs are sometimes called failed stars. Most of the time, they cannot be noticed in visible light. We usually detect them in infrared. So they wander through the universe but hide from our eyes. The interesting thing is this: brown dwarfs are the missing link between planets and stars. They show us how stars form and where that process can fail. The universe does not always fit neatly into star or planet. Sometimes it produces strange beings stuck in between. Brown dwarfs are the universe's children that never managed to become stars. 8. Dark matter, the universe's invisible skeleton. When we look at the universe, we see galaxies, stars, and planets. But what we see is only a small fraction of what the universe actually contains. Most of the universe is made of dark matter. Dark matter is invisible. It does not emit light, reflect light, or show up directly in telescopes. But we can detect it through its effects. Galaxies, based on their visible mass, should not be spinning so fast, yet they do. They should fly apart, but they do not. That means there must be an extra gravitational pull holding them together. That pull comes from dark matter. Dark matter surrounds galaxies and galaxy clusters, holding them together like an invisible web. That is why it is often described as the skeleton of the universe. What dark matter truly is, however, is still unknown. We don't know what it is, but we know what it is not. It does not behave like normal matter. It does not interact with light. We only notice it by observing how it bends space and affects objects. Dark matter holds structures together through gravity, and it can also distort the path of light. That allows us to detect something invisible indirectly. Scientists think dark matter could be made of a still undiscovered fundamental particle. One possible candidate is what they call weakly interacting massive particles. But one thing is certain: most of the universe is made of something we cannot see. Galaxies are the exception. The real universe is held up by an unseen structure. 7 quasars, the brightest monsters in the universe. There are points in the universe that shine brighter than an entire galaxy. These are called quasars. Quasars form around supermassive black holes at the centers of galaxies. What makes them extraordinary is not the black hole itself, but the matter swirling around it. Before that matter falls in, it accelerates to incredible speeds. Friction increases, temperature rises, and one of the brightest lights in the universe is produced. A single quasar can be brighter than billions of stars, and all that brightness comes from what looks like a single point. Some quasars also fire jets from their centers at near light speed. These jets can extend far beyond the galaxy, stretching for hundreds of thousands of light years. Black holes are the darkest objects in the universe, yet they can create the brightest structures. Sometimes the greatest light is born from the greatest darkness.
6 cosmic voids, the nothingness inside the universe. When we look at the universe, it feels like everything is filled with galaxies. But the truth is different. Most of the universe is almost completely empty. These empty regions are called cosmic voids. Cosmic voids are enormous areas of space where there are almost no galaxies. It is not a galaxy cluster, it is not a star system. It is not full in any normal sense. Their scale is mind-breaking. Some are hundreds of millions of light years wide. Even traveling at the speed of light, it would take millions of years to cross them. Why do these voids exist? As the universe expanded, matter did not spread out evenly. Gravity pulled matter together in certain regions. Galaxies formed along filaments like threads, and in between those threads, almost nothing was left. Those vast in-between regions became cosmic voids. People sometimes think there is absolutely nothing inside them, but that is not entirely true. There can be small amounts of gas, dark matter, and sparse particles. But there are no stars, no galaxies, and almost no light. These are the quietest, most lifeless places in the universe. The key thing about cosmic voids is simple. Most of the universe is not full the way we imagine. It is made of emptiness. Galaxies are the exception. The universe is mostly void. 5 fast radio bursts. The universe's sudden screams. Sometimes the universe shouts for a moment, then becomes silent again. There are signals we detect that even scientists don't recognize at first glance. One of these is fast radio bursts, or FRBS. FRBS are radio signals that last only milliseconds, yet release an enormous amount of energy, comparable to what an entire galaxy could produce in a short moment. They are so brief that they vanish faster than a blink. In the last few decades, hundreds of FRBs have been detected. They come from very distant galaxies. That means the signals reaching us may be echoes of events that happened billions of years ago. What is especially interesting is that some FRBs come from isolated galaxies, unexpected environments. This suggests their origins could be far more diverse than we assumed. Scientists think these bursts may be linked to extremely dense, compact objects like black holes or neutron stars. The strongest candidate so far is magnetars. It is thought that FRBs could be produced by sudden fractures or disruptions in a magnetar's magnetic field. These events can release an unbelievable amount of energy in an instant, which we detect as an FRB. But there is an important catch. Not all FRBs may come from magnetars. Some do not fit that explanation. That suggests FRBs might not have a single cause. They are still not fully solved. But we do know one thing. The universe is full of sudden, violent events, and sometimes we only catch them as signals lasting a few milliseconds. 4 rogue planets.
Worlds without a star. Some planets in the universe have no star at all. Rogue planets are planets that drift freely through space without being bound to a parent star. They move alone through the darkness. Since they don't shine like stars and are usually extremely cold, these planets might be far more common than we think. But because they emit little to no light, they are very hard to observe directly. We can usually detect them only indirectly. So far, only a few have been discovered. Scientists often find them using gravitational microlensing. When a rogue planet passes in front of a background star, it briefly bends and magnifies that star's light. Rogue planets are invisible, but their effects can be detected. They can form in two ways. Some are torn away from their stars by violent gravitational interactions in young planetary systems. Others may form directly from gas and dust clouds without ever having a star. Without a sun, their surfaces are dark and cold. But because of internal heat, they may still have liquid oceans hidden beneath thick layers of ice. Rogue planets show us something unsettling and beautiful. A world does not need to be tied to a star to exist. The universe is lonelier than we imagine, but also far more creative. 3 magnetars, the most dangerous magnetic monsters in the universe. Magnetars are a special type of neutron star with an unbelievably strong magnetic field. They are some of the densest and most extreme objects in the universe. They can compress more mass than the Sun into an area the size of a city. That crushing density amplifies their magnetic field to insane levels. A magnetar's magnetic field can be trillions of times stronger than Earth's. And magnetars are among the most dangerous and unstable objects in the cosmos. If one came within even 1,000 kilometers of Earth, it could tear apart molecules in our brains. And it wouldn't stop there. All electronic systems would collapse. Phones, credit cards, hard drives, anything that stores data would be wiped. 2 neutron stars, the densest matter in the universe. Neutron stars are among the most dangerous forms of matter in the universe. They form when a dead star collapses into an extremely dense object. When a star runs out of fuel, the outward pressure disappears and the star collapses under its own gravity. During this collapse, atoms are crushed, electrons combine with protons, and matter becomes an ultra-dense object made almost entirely of neutrons, a neutron star. The resulting star is very small, yet its mass is close to the Sun's. That is why a teaspoon of neutron star material on Earth would weigh as much as a mountain. 1 black holes, where time is distorted. Black holes are the corpses of stars. What do you think would happen if an astronaut approached one? Black holes are the densest objects in the universe. Their gravity is so strong that it doesn't just affect matter, it affects time. According to Einstein's theory of relativity, as gravity increases, time begins to slow down. So as you get closer to a black hole, time does not flow the same for everyone. What happens if an astronaut approaches? As the astronaut gets closer, they would not feel anything strange. Their heart would beat at a normal rate. Their watch would tick normally. Their thoughts would flow normally. For the astronaut, everything would feel the same. And that is where the weirdness begins. While everything feels normal for the astronaut, the scene looks completely different to someone watching from far away. The astronaut would appear like a slowed-down film frame. Their movements would seem to slow, as if time were freezing. The astronaut would never realize they are freezing, but to an outside observer, time would look as if it had stopped. As the astronaut nears the black hole, a difference in gravity appears between their feet and their head. Their body begins to stretch, like spaghetti. In science, this is called spaghettification. Black holes do not stop time. They decide whose time flows how. And that is only one of the strangest things in the universe.